Mathematical functions. This is an introductory lesson, and it's a digital lesson. So it starts out with explaining to students that function is a mathematical rule that states that for every input, there is only one output. And so we see here we have a diagram called a mapping diagram. The input or the domain is on the left, the output or the range is on the right. So the next slide shows this mapping diagram, and it's like a flow chart showing the input and the output values. So you just follow the arrow 3, 2, 6, 1, 9, and 3. And you can see here that every input on the left has only one output. So on the next slide, students are just going to determine whether these are functions. So they want to look and see whether every input has only one output. This first diagram is a function. The second diagram is not, because 12 has two different outputs. And the third one is a function. Now the next one, they're explaining that a mapping diagram can be used to create ordered pairs. So you want to type the domain first and the range second, and that creates your ordered pair that you can graph on the coordinate plane. So here we're just going to type in the domain. So with -6 would be 4, -5, the domain would be 3, here, 3, and -7 would be 5. 5, -7. And then the next slide, they're just going to type in the range for the ordered pairs. So 6, -2, 4, -3, and 8, -1. Slide 7, students are going to look at these ordered pairs to determine whether they represent a function. So every input can only have one output. So this first one is not a function because 4 has two different outputs. The second one is a function, and the third one is also a function. Now we're going to graph some numbers on the coordinate plane. Students are just going to click and hold on these points and put them into the correct place to show these ordered pairs. So for the first one, 1, 0, they're going to start at the origin, go to the right 1, and then stay right there for 1, 0. 3, 2, to the right 3, up 2. -3, -4, to the left 3, down 4. And this is a function. Now students are shown what we call the vertical line test, and they can use this test to show any graph on the coordinate plane and determine whether it's a function. So they're just going to click on that red line, and they're going to use the right arrow on their keyboard to move it to the right. Now, if it's a function, it will only touch the graph in one place at a time. So here you can see it touches the graph twice, so it's not a function. The next slide, we've got two more. So here again, they click on the red line and then the right arrow. Here they can see this one is a function and only touches the graph one time. So they're going to put an X in the box. This one, we're going to use the left arrow on the keyboard. And it is not a function because it touches more than one place. The next graph, we're going to do the same thing. Not a function. And then this one, you want to show this to the students. This is also not a function because it touches the graph in an infinite number of places. So neither one of these are functions. Now on the next slide, they're given the equation for a line, and they have to place these 3 points somewhere on this line. And then they're going to use the vertical line test to see if it's a function. So here we have an equation y equals 2x plus 1. We know the y-intercept is 1. So we know there's going to be a point at 0, 1. The line crosses the y-axis at 1. The slope is 2, so we can go up 2 to the right 1. And another point on the line could be right here. So they just need 3 points that are on that line. Now let's try the vertical line test. We're going to pretend there's a line that goes through those 3 points. Will it ever touch the graph in more than one place? Oh, it does not, so it is a function. And they're going to type in yes in the box. Okay, now we're shown some tables. So same thing, every input can only have one output. So you can see this is the x and this is the y. X would be the input, y would be the output. So here looks like the first one. Every x has only one y, so that is a function. This one we've got 2 inputs that are 2. So we have a 2, 0 and a 2, negative 3. So there's 2 different outputs, so that cannot be a function. This one is a function. And the last one is not because 0 has 2 different outputs. Now the next slide explains how we can use an equation to represent a function. So if it's an equation written in slope-intercept form, y equals mx plus b, it is a function. But we want to know if a point satisfies the function. So you have the point here, 3, 5. If you replace your x with 3, do we get a y equals 5? So if we do this, we can see if we replace the x with 3, we get 6 plus negative 1 is 5. So yes, our y is going to equal 5. So this point does satisfy the function. Now here we have another equation. Students are just going to type yes or no. They're going to place their x value in place of x in the equation and see if y equals their y value. And they're just going to type yes or no. Now they have a function table. So we have the x values. They're going to replace x with these numbers and then see what y equals. And then it explains that there's another method for indicating a function. If we see an equation that looks like this, in place of y, they have f of x, which is f and then an x in parentheses. These are not variables. This just indicates that this equation is a function. Now, the very last slide, students are going to drag and drop these terms into the correct place in sentence frames. So they just click and hold on the edge and then move them into place. So a function is a rule that states that for every input, there's only one output, and they can finish the rest of that. So this is the digital lesson on functions.